You're listening to Let's Talk AI.
Welcome to Let's Talk AI. Today's guest is Mark Crowley, Associate Professor in Electrical and Computer Engineering. So, welcome, Mark.
Hi, Harold. Thanks for having me. It's nice to be here.
Today we're going to jump in to understand a bit of your background. How'd you get into AI, and where you're going with that now? So, let's just wind back the clock a bit. And
Yeah,
how did this all start for you?
trying to think back to it. So I'm from Toronto, so kind of nearby area, right? And I guess I was in university. So I did computer science at York University, and I guess graduated 99 from the undergrad, right? And I did actually did BA in computer science. So I was doing all this extra like on the side. I was doing philosophy and social political thought with programming on the side. But one of my favorite things in computer science was the AI courses, the programming and logic and things. I fell in love with the idea there. But then I went to industry for a few years. IBM worked there, and then for reasons kind of decided to go back to grad school and pick up AI, which I went to UBC to do my master's and PhD. And when I got there, AI was very different than I had seen in undergrad, so it was interesting.
Okay, different in what way?
Well, like around that time, there was all these kind of like ages of AI development and stuff, right? Like essentially what I learned in school was there was a lot of focus on logic and rules and building things up. So I don't know if you remember, like when I was young, the chess program they're playing, Gary Kasparov, Deep Blue was this big thing. So that was kind of like the pinnacle of this logical approach to AI. But at the same time, all this other things were happening using statistics and probability, and not even neural networks by that point, but like building towards that. So when I got to grad school, everything was like, oh, AI is all probability statistics, which is good because if we want to have something as complex as human thinking or even animal intelligence or thinking, you have to deal with an uncertain world, right? So when I did my grad school, a lot of us dealing with probabilities and how do you build rules and make a computer do something useful if the world is uncertain and it doesn't know what's happening, it's unsure about things, right?
Okay, so you did your PhD there, and then you landed back here in Waterloo after that, or what?
Not
How
right
did that
away.
happen?
Yeah, so I was at UBC for a master's and PhD. So I finished there 2011, and then I did a postdoc in the States, so in Oregon at Oregon State University. Go Beavers! Uh, and did some work there with Tom Dietterich and his research group, which was really useful. And he was in an area, and it was actually related to forest fire, like prediction and mitigation, which had been somewhat related as a topic to my thesis, and so it was a perfect fit. And then I was there a couple years, and applied for faculty positions, and Waterloo was perfect because it's near home. My parents and family are still in Toronto, and it's a great school for all this kind of stuff. So it was a perfect fit.
Awesome. So let's come back to the forest fire thing in a few minutes, but let's go back to when I checked out your profile on the Waterloo website, and it says machine learning optimization and probabilistic modeling. So that's a big lot of words there. How do you boil that down into simple language? Where's your focus?
Yeah, I actually touch on a lot of different things, but I guess the focus, these days is always coming down to trying to find models that can and make the assumption, say, oh, what's a model? So what is AI machine learning, right? You're trying to get a computer to do something that we would call thinking, right? Everybody would like debate whether intelligence is the right word for this, but essentially that's what we're doing, right? We know that people can do complex things like play chess and drive cars and plan and decide how to fight forest fires. So if our brain is a computer should be able to do that, right? The thing about AI over its history has been they've focused on trying to do things logically, and then they now have added in probabilities and statistics to deal with if you don't know what's going to happen next. How do you estimate what's the most likely outcome, right? That's an important part of intelligence. And then most recently with deep learning, which is what most people mean by AI machine learning these days, it's about simulating a bit of the complexity that our brain has, that it's not just about the probability of something happening, but learning from many different examples and synthesizing them. But so I focus a bit more on reinforcement learning, which isn't in that list you listed there. So I would say that's my core one. But I'm always been a bit on that side of logical and probabilistic AI, where I'd like to know what it means and have a structure to how it works, which is not how everyone in AI kind of focuses on things.
Okay, so we think about this as a pendulum, and it started way over here on the one side of logic. It's swung all the way over now to the more give me the data and let the machine learning model figure it out. We seem to be coming somewhere into the middle now. Um, a combination of logic and machine learning. You call it different names, probabilistic and things like that. Is that a reasonable way to describe it?
I mean, it's definitely a discussion that's ongoing with everyone, and it's like inevitable. I think that it will happen. There's been a lot of focus on, deep learning and these models that it's the data can extract out this behavior, these patterns we want. Um, but there's a lot of us who feel like at some point you're going to need more structure and you're going to need logic and even causality. So some of my recent focus has been on like, can we get causal kind of meaning out of things? And causality is just A causes B. So you hit your foot, you press down on the brake on the car stopped. It stopped because you pressed the brake, right? Pure kind of deep learning models just see those two things happening and say, well, they seem to happen together, but whether one caused the other isn't automatically in there, right? And that seems like an important aspect, right? That's what science is always about. So I think there is a movement back that direction, but it's only just starting. Um,
Okay. Earlier, you mentioned the words finding a model that fits. What does that mean, finding a model? I mean, obviously, you're not searching in a dumpster of models here. How do you find models? Are you taking some that are there and iterating, adding new aspects? What does that mean?
yeah, if my student said that, I'd be like, "What do you mean? What's a model?" So it's a good question. Like model is a very overused word, and we just kind of use it because we don't know what else to say, right? We got this big complex box in our computer that basically takes in some information and gives us out some other information, right? So that could be a prediction of what move to make in chess, based on the board, or how to steer your car or what to do next. You could be labeling this image as a cat or a dog. you know there's some output, and so model, I would say, is just generally anything that takes those inputs and gives you some output, but you've decided what that model does, right? And so, yeah, finding it is, I guess, there's different aspects. It's like, what is the box made of? What is the model? What kind of machinery does it use? And then once you've decided on the machinery, how do you like tune it, right? So most of the current ones have essentially thousands and millions of little knobs on them that are being tuned in order to get the right output. Um, but there is deciding, what the box is made of in the first place, and then how to adjust all these little knobs.
Okay,
So it's
so you
different.
mentioned forest fire and fighting that earlier. If you start from a clean slate, do you go and import a model from something similar or different, and then start, like you said, adjusting all the bells and whistles here, or how do you go about tackling that challenge?
Yeah, because forest fire is interesting because it's a real world problem with a lot of noise and uncertainty and messiness, which is good because sometimes as researchers we want to prove that our box and its knobs work well, so we get toy problems and kind of validate that. But real world things like forestry and forest fire are just so messy. You've got satellite images, you've got records that may be incomplete, you've got humans doing things that is their best policy, but they didn't write down a program to say how they did it, right? So yeah, you usually would take like they have their own models for predicting, what's the outcome of the fire this year, and like, is it going to be a large season or where is likely to burn? So you try to predict where a fire is going to be. I guess in that domain, it's a lot of it is trying to find models that are working really well in other things like automotive systems or advertising or just fun image generation, um, and things, and apply them to something useful and important like forestry, or something like that, and find a good fit for it. So in forestry, that could be the satellite images, and you're trying to learn from those images how fire works and spreads, and get a better model that can predict where the fire is going to be next.
So was that, you said you did this in your PhD? I think the forest fire
In
scenario
PhD, I
or
started
started.
dealing with trees, but it wasn't actually a forest fire. There was a pine beetle epidemic at the same time I was there, and that's how I got onto the topic. Actually, at UBC, the computer science department is right beside the forestry department. So UBC is a forest province, right? So they have a forestry department. It's a beautiful building. You walk in, the Tim Hortons is there, so you walk into it a lot, and you realize the moment you come in, this is the forest, usage building because it is made of so much wood. There's huge beams everywhere, but they have it's a sustainable, forest management. So trying to find ways to harvest and replant and have a way that will cycle. But at the same time, they were having a big outbreak of mountain pine beetles that were killing the trees, and it was a result of previous policies that had stopped all the fires. So they were trying to see if there's ways to use AI to help with the predictions about that and optimize it. So I did my thesis on doing some of that because it's such a larger model than such a larger space than other data sets people would use. It's hard to even do the computation on it because the spaces are so large.
Okay, so you earlier talked about satellite images and forest fires. Are these images during the fire, when the fire is burning, before? What kind of images are you talking about? Because I mean, we always see all these satellites zooming by. What are they collecting? And is there some there just collecting certain images you need to be able to help on your prediction with the model?
Yeah, I think the stuff we're looking at are looking at really previous fires from previous years where we know what happened and trying to use that to train models to understand the dynamics of it and see if there's anything we can add to models that people are already using that maybe are simpler. Um, and You can do it in real time, but in real time, people need very fast responses. So you'd have to have a system that's very well proven um, and have high confidence, right? So in domains like this, especially, and in other ones like in medicine or on these safety conscious ones where you're going to get advice in real time, they'd want to know how the model is making its decisions or not. So it's kind of a big issue there. But yeah, we're using historical data um, and trying to see if we can predict things that would happen and then mitigate them. And so hypothetically try different things and see what would have happened.
Okay, interesting. We had a conference back in end of November, and we had the head statistician for Canada who talked about the satellite information they're collecting. And one of them that they're collecting is related to moisture. So they're evaluating the lakes, the dry areas, a whole bunch of these. And instantly, I actually was thinking about your work and I was wondering, gee, if you knew where the drier areas are, you could probably know once the fire starts, you know which direction it's going. And but this is like proactive,
Yeah.
you
Yeah,
know.
it's actually so I was actually at a fire conference in Edmonton a couple months ago. I just wrote a blog post about it recently on my website because I wanted to reconnect. We have a strategic NSERC network that I'm part of that's based out of Edmonton that is doing technology and some NAI with forest fires. So it's trying to meet people from that network there. And there were talks exactly on this, but people in that domain of forest research analyzing how they can use moisture and wind and various things to predict better what would happen at high scales, like for the entire continent or a province. Um, so then you could use those as input, and those models could be given as part of your knowledge, but then you try to also use images. The thing about machine learning is that you can build a new box that basically is a blank slate and give it a bunch of inputs and train it on the output. Um, and so if you have these things that work really well, you can utilize them and then basically level up, a new model that integrates them together, which I think is really a part of what intelligence is synthesizing lots of different pieces of data and knowledge and using them to do something useful.
So you're not doing this all on your own, I assume. You probably have a small team of people here at Waterloo that you're working with, students and things.
Mm-hmm.
Talk to us a little bit about who's on the team and what kind of work are they doing.
Yeah, I have a small group of grad students in my department in ECE. I guess three PhDs and three masters at the moment. So I had a few PhDs graduate in the last year and the year before, and they're off doing fantastic things. So Sriram Ganapathy Subramanian was my PhD student, finished last year doing reinforcement learning on like multi-agents, and he looked a bit at this forest fire problem as well. So if you had multiple firefighters out in the domain, how would you do planning amongst them in these optimization algorithms we have for like basically they're often used for game playing for reinforcement learning, but we're trying to apply them to real world domains like driving and forestry was one of the things he was looking at. I also have some other students looking at things in autonomous driving. So that's a big thing at Waterloo. We collected a whole data set last year with the team, the last couple years, with a corporation that lent us a car with sensors on it and everything. We collected 60 people driving around the region, um, collecting data about their driving. So we're trying to do human driver prediction, um, driver behavior learning, we're calling it. On that project. And so that data is all collected and done now. So we're trying to basically clean it up and make it public and do some results on it. And then there's also some students doing even medical imaging research. Sometimes I forget what the other ones are doing, but those are the main topics right now.
Okay, so autonomous is, like you said, a big topic of interest. I know we have the Watana bus on campus here.
Hmm.
Um, what's the bigger picture? Do we ever, or what's the framework on how we're going to get into autonomous driving? Or is it always going to be like we start to an assist mode and, et cetera, et cetera? I know we have those lane avoidance and things like that today.
Oh, yeah. Yeah, I'm starting to wonder whether we're really going to ever have the thing where it does all the steps because I mean, it's always been a bit wary of that from my point of view. It's like, well, the final step of it is going to be, policy. Like society has to accept these cars as driving around independently. And so we have to do that as a society to kind of accept it. We've done a lot to allow testing. So in Waterloo, they can test these cars on the roads. Um, and there's quite a lot built in. So my car, we've got really good, lane keeping and driving. So when we drive to Toronto, it handles a lot of the 401 pretty well. And you're watching and holding the wheel, but it's doing most of the grunt work, right? Doing city driving is fundamentally harder, and people can do it, but it's a matter of trust. An interesting part that isn't being done a lot is weather. So, like, sure, it can work in California, but will it work in Waterloo in the winter when we have our snow whiteouts and everything? And no system I've seen can handle even the slush. On the weekend, we were driving back, and there was a little bit of sleet coming, and it covered our radar, and the whole system went offline. So you had to drive completely controlling. It's like that's pretty sensitive, right? But that's a technological thing. People have to find ways to make these sensors um, clear all the time. Um,
Probably need
yeah.
windshield wipers on your
We
sensors,
could, I guess. It's not my area. We go to mechanical people can figure it out. But yeah, I think so. I think that's important. But I think it's also like as we keep going up this curve, like we're getting to this 80 or 90% safety. They can drive all these situations if we trust them. But that last 10 or 5% is going to be harder and harder. And it seems like it's going to be a while, if ever, before we really have them doing all the driving, if that's what people want.
I've seen some things on long haul trucking as an ideal scenario because you know it's a repeated route. Moving parts from A to B, from factory A, tier one to supplier to tier one, things like that. Whereas, yeah, as much as we'd like to think we leave our house in the morning and drive the same path to get to work each day, of course, we got to go get gas and we got to go to the grocery store and there's different variances. But do you see maybe a less personal, maybe more industrial application as being the lead on autonomous?
Yeah, no, I always say that. I think yeah, I definitely would never advise anyone to go into truck driving. Long haul truck driving is a career like that seems optimal, like very easy, low hanging fruit to say we could just replace all that because highways are fairly simpler environment, even though they're faster. Less happens. There's less options, right? And the trucks can do that. Um, and it's also something where we can regulate it and say these trucks have to follow this rule. Maybe we could even have dedicated lanes, for autonomous cars or trucks on the highway. Whereas city driving is always going to be the hardest part. So the last couple kilometers to the delivery is different. Um, and that requires, I think, a bit more of another leap in reasoning for these systems that they take into account what's happening and have, common sense and causality because just having a deep learning system with lots of sensors isn't going to be enough to capture. If you've never seen it before, um, you have to have a way to react to response a situation you've never seen, right? And yeah, well, I think the truck driving is a good one, and even for commuting, if they put those lanes that are sort of for car sharing, at some point have those be car sharing or AI, and then have those cars, drive fully autonomously, it might be a benefit.
What about the simplicity thing like ion trains here? Why do we need a driver there?
Oh, that's right. Um, I don't know. Sometimes it's good to have, a person who's around who knows how the system works for special cases. I'm a big fan of that. Like the last, couple percent of complexity, like you can make it work maybe, but having a human there to do that is good. I mean, sometimes in Vancouver, the trains don't have drivers on them, so it's perfectly possible. Um, that's more, again, a societal decision whether it makes sense.
Yeah, but you ride the subways in Toronto, and most of the time you can't see the driver.
You never see a driver. Yeah.
You know,
Well, in rush hour
doesn't
in
mean they're
those
not
stores.
there. They're in their little cubby hole, locked away, and at the front or rear or wherever they are on the train. So may just happen, and then we don't even realize there's no driver.
Yeah, that's true. Yeah. I mean, I don't know how much that would save you in terms of like efficiency or people, but like I said, if there's a special case and someone needs to decide, someone should stay on a train or not, that's what the staff would be for, right? But that's not a hard problem, obviously, because it's on track. You could do that with AI. So there's some things, in our life where we could do that automatically. Like a grocery stores is another one. I'm like, why do we still have to have somebody go and scan all those things? Like even the self checkout that we have, they've gotten better, but they're very finicky. There's no reason why you couldn't just have location sensitive kind of sensors on things you've picked up and essentially walk out and buy things as you go.
Yeah, there's that Amazon Go is that exact model. They make a smart cart, and as soon as it enters the cart, it knows what's in there, and then bills it to your credit card, and you just put it in a box and you leave. You don't talk to anyone. But so again, I'm going to stick on the autonomous thing, going to a smaller scale. It seems to be taking a lot of adoption in factories. Where there's more pick and place robots going around factories. All the automations. We're all ordering things from Amazon. Places like this. Um, is your team working on any of those kind of things?
No, not right now with factory stuff. I mean, we talked to some people a couple times about it. Like you have these conversations with local companies who are looking for advice, and so I've had discussions about it, but nothing at the moment. It's interesting, yeah, because it's a domain where you can again control the environment and say, well, this is where the people are allowed to go, and this is the structure. But then you still have a pretty flexible system that can go and find all these irregularly shaped objects and place them, right? Um, so. Yeah, it's definitely a good way that it can be used, but it doesn't necessarily require even the latest AI to do that, I would think.
Okay, so just some final thoughts here. AI is ramping up, and jokingly call it the AI tsunami. What's your thoughts looking forward? What do you see over the next 4 or 5 years? How society is going to change? What areas?
Oh, it's a big question. Like, what's the next big thing? Or, well, where it's going now, because right now everyone is talking about Chat GPT and these like image generating art, AI art things. That's very interesting. So we call that generative models. So these are, deep learning that is not just making a prediction and labeling cats and dogs or driving a car, but creating an entire new, we'd call it an instance of the data set, but essentially instead of labeling pictures, it generates a picture that fits what you described. So things that's moved a lot forward, but it's interesting because there's controversy about it, like the way they're trained on the data they use. They basically take everyone's data and learn these very large models. Um, so it's very exciting, but it's also lots of questions about, what's the best way to do it, and can everyone use this, or is it only going to be something that the largest computing resources possible can make happen? Um, so I think it's still going to go back to like we were saying before that we need to swing that pendulum the other way a bit and talk about meaning and models that have structure in them a bit, because these are kind of brute force solutions. Not brute force. There's definitely some new innovations have happened with transformers that people are still trying to understand, but it works because there's a lot of data and a lot of computing. So trying to understand what that means will be interesting. As a society, I think people reacting to that is going to be interesting. Like as teachers, instructors, we're talking about ChatGPT all the time because it generates very good text. So if you're assessing students on writing essays or descriptions of things, a lot of that can be automated now, which isn't necessarily something we thought would be automated this quickly. So it leaves us with lots of questions about what's the right place for it, and is there ways to regulate it or understand it or even detect it. So I think a very interesting research direction will be like, can you detect this was generated by an AI or not? And that's actually quite a hard problem.
Yeah, it's not just essays. One of the students got creative and put the question into Chat GPT, write me a SAT solver for, and they put in a problem, and it went and generated all the code. So this isn't just in the arts or essay writing courses. This is across every part of the university.
But what I'm pointing out to students when we talk about this, because I actually just face it directly in my classes, because I'm teaching a machine learning class this term and a fourth year algorithms class. So he's going to say, well, I know this thing is might think is available to you, but keep in mind these models are optimized to be realistic, to sound like they're correct, or to give you an image that looks good. They are not checking for correctness, right? The text ones generate words that sound like they fit together well, and grammatically it's perfect, but it doesn't know it's the right answer. So it'll generate you code for your stat solver, but it might not be correct. And it's like it'll write your essay, but it might just make up facts because that's what it sounds good. So hopefully that makes people worry about using them for that kind of thing. And also, if you're using it as your search engine, it's not even the same as checking Wikipedia, because Wikipedia is watched by thousands of people who are, experts on these subjects, and it will get updated if it's wrong. Whereas ChatGPT will tell you something, and no one will ever check if it's correct, even though it's very impressive that it's so smooth. Right?
Yeah. Well, exciting times ahead then. Again, thanks for joining us today on Let's Talk AI. And we got a little more insight into Mark Crowley and what makes you tick. So thanks again.